Hello everyone, I'm Amir Hussein. Welcome to this training video. In the previous video we talked about WRF pre-processing and we went through all the required steps to run WPS, from defining model domain and running GeoGrid to extract meteorological variables and running OnGrid and MetGrid. Just let me to show you one of these MetGrid outputs. This is our model domain, the parent domain. This is our parent domain, and let me show you the nested domain, one output from our nested domain. And this is our nested domain that covers parts of the Persian Gulf. Okay, now that we have finished WPS, we are ready to run the WRF. Okay, let me open a new tab. I go to the WRF directory. Just one point, just let me say you one point. This important point that I should tell you is that WPS directory and WRF directory should be in the same directory, should be besides each other in the same directory, and this makes compilation much easier. Okay, go to the WRF and go to the test directory. Inside the test directory you can see several test cases, but our test case is actually a real case. The other test cases are idealized cases. For idealized cases you don't need to run WPS. So go to the EMReal. Inside EMReal, or which is for running a real case, it has a name list, open name list at input, and inside this name list you have several sections. The first section is related to time, related to setting dates and time, and the second section is related to domain configurations. The next sections are related to scientific issues like physics, microphysics, and dynamics schemes, and so on. Okay, so you need to set these parameters. For example, run days, you can set it, it depends actually on your WPS. Let me check my WPS. In the WPS we had run WPS for, let me open name list, for 2 days. Okay, so you can set your run days to 2 days, or you can set your run days to 0 and run hours to 48 hours. Both of them are the same. So I just actually these parameters are already set. I just wanted to show you how you can deal with these parameters and prepare your name list. And so these parameters should match the parameters you have in name list. And also for the second section, these parameters should match the parameters related to your domain or GeoGrid section in the WPS. So for example, we have 45 points for the direction west to east, so you should match your west-east points to 45 for the first domain and also for the second domain. The second domain is 46, and you can see that in the name in the WRF name list, both of them match. So they are okay, but let me tell you about this variable, this parameter. This parameter means that if you set it to 60, it means that every 60 minutes you will have WRF output written in the output, in the netcdf output. So you can change this value to like 30, or maybe 90, or 120. That means that if you set it to 120, it means that every 2 minutes you will have your output. The result, you will have the WRF results written in the netcdf output. And the other important point is frames per out files. Maybe this variable or parameter is its default value is 1. If the default value is 1, it means that every output will be saved in a single file. So if you want all the results of the WRF to be saved in a single file, all the results in one file, it's better to put a big value here. But if you set it to 1, it means that if you have like 10 results for your output, you will also have 10 separate files. Maybe post-processing 10 separate files might be a little difficult. So I recommend you to put a big number here, so you will have all the results in one single file. The other important variable is dx and dy, which here it means 30 kilometer and 30 kilometer for dx and 30 kilometer for dy, and these values should match the dx and dy in WPS name list. Okay, and also I parent start and j parent start, this 15 value matches this 15 value in the WPS name list. Okay, you can get a comprehensive information about these variables in the WRF documentation. The other section is physics, and there are some variables here, parameters here that you can change, dynamics and so on. Just let me show you the WRF documentation. This is the WRF documentation. It provides comprehensive and detailed information about all the variables and parameters you can find in the name lists. For example, if you want to get some information about this MP physics, you can search about it in the WRF documentation, and here it has a section that fully discusses this variable. For example, if you set MP physics to 1, it means that it will use Kessler scheme with these characteristics. If you want to know more about Kessler scheme, you can search about its article and read it. Or if you set MP physics to number 2, it means that it will use Lin scheme, which is more sophisticated. The important point is that you cannot freely change these parameters to any value you like. These parameters should be consistent with each other. So if you just randomly change them, it is possible that they will show you some errors. Okay, just let me run the WRF, and for the first section of running the WRF, you need to, as the first step of running WRF, you need to link your WPS metgrid data here in the WRF directory. So let me get the path of WPS, go to the WRF directory and link them here, met, and put a star at the end and a point. Now you have all the metgrid files, metgrid output here linked in this WRF directory. The first step is to run real program. If you run real program, it makes the initial condition boundary conditions here, WRF input and WRF boundary. This is necessary for running the WRF model. And now you can run the final program, which is WRF. If you run it, it will start step by step. Just let me show you one important point. If inside the name list some variables are not correct, let's say this variable num net grid levels, this variable actually depends on your meteorological data, FNL data or aerofoil or whatever data you have used. If this variable is not correct, for example, let me modify it to something else, something 37, for example. If I run real, it raises an error, and inside this error it may show you what the problem is. For example, here it is showing you that this parameter does not match to the parameter of your WPS. So you can find out about the error, and you can actually edit your name list. Okay, I run WRF again. Now you can see that it has been started from the start time, and it continues. These are actually minutes. These are minutes. And after 60 minutes, it writes the output, it writes the results in the output. This is the output for the first domain, and this is the output for the second domain. It continues 50, 51, 52, 55, 6, 7, 59, and this is the second time slot, and this is for the second domain. So you can see inside your WRF outputs. These are actually our WRF outputs. It's possible to visualize them while the WRF is running. You don't need to wait until your run is finished. You can visualize your output simultaneously with your WRF running. If I open it, let me show you albedo. Yeah, this is the albedo, and you can see that we just have four time slots, and it will be increasing because your model is running, and for sure it will be increasing. So now we just have 4 time slots. If I visualize it again, if I open it again, albedo, now it is 6. So it means that WRF is running, and data and results are saved and stored in the output. This is for the first domain, and this is for the second domain, albedo. Yeah, covers parts of Persian Gulf. Yeah, and you need to wait for it to be finished. And one final point is that if you show this process to an experienced WRF user, it is the speed of these processes are surprisingly fast for an experienced WRF user, because and the reason is that if you go to the WPS and open name list, the reason is that the number of points, the number of grid points is very low. Actually, a usual WRF domain has much more points than this value, maybe more than 100 or even 200. So it means that the less points you have, and also the more value for the time step, it means that you will have lower resolution, and the lower resolution you have, you will have a faster speed for running your WRF. So if I had here, let's say 100 points, and 100 points for the second domain, it's the final process will be much slower than this. And also, if I had, instead of 90 seconds here for the time step, if I had lower value for instead of 90 seconds, let's say 60 seconds or maybe less than that, it means that the temporal resolution of the model is improved and increased, and I will have lower or a slower process in the WRF model, in the WRF running. And one other point is that this is actually a general point, a general guidance. For every 10 kilometer inside your model, inside your configuration, for every 10 kilometer, try to set time step no more than 60 seconds. For example, here we have 30 kilometer, so 3 times 60 means 180. So to set a value more than 180 is not recommended for this configuration. So for any 10 kilometer here, it's better to set a time step less than 60 seconds.